Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Turn that up. And this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And I have regular contributor Richard as VK7ZBX.
Good day.
How you going?
I am very well.
How's your day?
Yeah, fantastic.
Living the dream.
Fix more things than I broke, so it's got to be happy with that. Yeah.
I love it. Now, Richard's in the studio for a few reasons. One is now the magic of radio, which will probably go terribly wrong knowing this, but anyway. Now that was a slightly better transition, wasn't it? Remembrance Day Contest.
Yes.
Now, I did a very quick count. As last night, so it's probably a few more. I'm hoping a few more than this by now. But our counts are looking good.
289, I think I might have saw last night.
There you go. That was about right. So yeah. I split them up. We've got the one VK0, which is VK0 PD, I think it was.
Paul, yeah.
VK1, VK2. VK3, the outstanding logs there, so outstanding from the point of view of numbers. VK4, VK5, VK6.
Pretty good numbers from VK6 compared to in the past, I think.
Well and truly.
Yeah.
Well and truly. Well, actually, and pretty good numbers from VK2 and VK3, given they haven't been high in the past. They, given the population, yep. That's where everybody is, and it might be indicative that they're both in lockdown.
Lockdown's good for contests.
Correct. And then VK7, so we're at 51 right at the moment, which is fantastic. And then there are 5, there were a whole lot more ZLs. There was only
I didn't actually work any of the ZLs. Hayden worked a few, he did really well.
I did a couple.
I didn't.
And I did one on 160, I think.
Nice.
Absolutely phenomenal signal on 160. So I don't know what he was running, but it was pretty impressive. Now, the other reason I have Richard in the studio, and I'll do this slightly better. That's a much nicer, much nicer transition. Now Now, have a look at this.
Apologies in advance for the fairly crap
Pictures?
quality.
No, this is all right. Now, what are we looking at here,
Okay,
Richard?
so last Sunday, people, regular viewers may have been following the the trials and tribulations of Murray and myself, putting our hand up to grab a 1.8 metre dish.
My-Tech dish. Very nice dish.
Let's just sort of build a frame for it and make it rotate and elevate. Shouldn't be too much trouble, they said.
Piece of cake.
So, some years later, it's been sitting in my shed really, really close. As you've been aware, it's had
Really?
it's had the actuators and the tracking system on it, and it's been really sort of close. It just needs some RF in it. So last Sunday, a random thought popped into my head, why don't I get this going? So I did, put the feed in it, bolted the transverter onto the back of it, and aimed it at the sun, and wacko, was seeing 12 dB of sun noise.
Now, tell us the story. Tell us the story of the sun noise. I think this is absolutely fascinating.
Well, we've both, you and I have both done it.
Yes.
With our 600mm dishes, where you basically hook up the gear.
Yep.
And we've got those little RF meters that we got off eBay for stupid dollars, $30 or something silly, and they're really quite good. Don't know whether their accuracy is good, but they're not after an absolute figure. We're just after a relative figure.
Fantastic.
So with the 600mm dish, you just sort of bang it on, you go backwards and forwards, and you go, yep, I'm on the sun, and you adjust your rifle scope, and it's all sort of reasonably straightforward. So in my youthful exuberance, I sort of plumbed it all up and shone it up basically towards north and up to the sky, sort of try and get some cold sky.
Yep.
And then sort of went across the moon, or across the sun, sort of looking for some sort of figure. I went, oh, and I sort of did it by hand.
Yeah. And that's indicative of the sort of speed you were using?
Yeah, not ridiculous.
Mind you, you're talking about a 1.8
That's
metre
right.
dish here, which is...
I couldn't see anything, and I thought, well, that's pretty strange. So then I hooked it back up and actually drove the thing quite slowly. And when I got to the point where I sort of thought it was aimed at it, I actually noticed that it slowly started to come up. And I was actually going a little bit too hard. The beam width is probably about a degree from nothing through to full strength and then to nothing again.
Yeah, so pretty sharp.
Which is probably, I think Rex predicted about half a degree. I think he might have said 0.2, but I think half a degree is.
Yeah.
So
which means you miss the sun, miss the moon real quick.
yeah, and of course it becomes quite almost a comical exercise to actually manually steer the dish to peak the signal up on your noise meter, and then to move the rifle scope.
And then it's gone again.
Yeah. So you sort of play the music.
So many
So I
music again.
I did sort of try. I sort of thought about saying to my wife, "Can you just do this?" And I thought, "No, look, it's all good. I'll do it." So it was like, and look, yeah, managed to get about 12.2 dB.
That's fantastic.
Which was really good.
Yep.
Rex was pretty excited when I rang him and told him. I think he was not sure if it was a combination of excitement and shock that I'd actually done it.
Progress.
Oh
my God.
But yeah, he did a few calcs and he said you should see maybe, I think he calculated 0.88 of a dB of moon noise.
Okay.
And he said that's the dilemma of one. He said, you know, once you get to 1.8, you start sort of getting into the bigger dishes.
Yeah.
And he said the problem is that in the school of the bigger dishes, it's a bit small for moon noise. Whereas once you get to 2.4 and 3.6, the amount of moon noise you see is more, so it's easier to sort of track. So I ended up hanging around till I think it was 7 or 8 o'clock that night, and sort of waited for moonrise because it takes a little while at my place. I've got about a 10-degree horizon to the east. So when it came up, once it got above the hill by a few degrees, I was able to sort of confirm it was about a dB-ish I was seeing.
Well, you were seeing it. That's
which was
key.
really good, and you were actually able to go backwards and forwards across it and sort of peak
and see it.
Yeah.
Okay.
So
and you reckon it was about a dB?
About a dB. Like it is quite a busy moment when you're doing it, trying to read this and look at this and look at that.
But you're physically seeing something.
You can actually see it basically come up to a peak and then sort of go down.
Okay.
So
that's
pretty
fantastic.
Happy with that. So I got all excited and got up at 4 o'clock on Monday morning to try and listen to the beacon. I can't be 100% confident, but I think it was off because the declination was quite a bit south.
Yeah. Okay.
And Rex and I had a bit of a look on the HB9Q logger, and there didn't seem to have been much activity. So there was a couple of comments about the moon is a long way south, so we'll have to wait for it to come north. So
Okay. All right.
So the plan is to try and I sort of left it outside too, and of course, as you know, the encoders don't like getting wet, so there was lots of shopping bags were sort of wrapped over things,
Okay.
but nothing got wet, so it's
No.
all sort of pretty good. So I want to try and do some more tests, and basically, I think we've come to the point where the tracking's quite accurate.
Yep.
But we've discovered that we've got to try and
Get it
calibrate it so that, because we've got no vertical access to like measure,
Yep.
because the thing's just mounted in the middle of a frame.
Yep.
So there's nothing to say that it's level and that the axis, the vertical axis is perpendicular.
Yeah.
So as you track, and I discovered it on a couple of trial runs, it would track quite well for an hour, and then it would gradually drift off the moon.
Yeah.
So
Which is indicative of it not being straight.
that's
not being,
right. Yeah.
Yeah.
But in reality, of course, if you could get it to track for an hour, that's pretty damn good.
Make a lot of contacts in an hour.
And as Rex alluded to, that the big boys,
Yep.
they don't actually track by numbers; they track by moon noise. So once they're on it,
Yeah.
they just basically
They have
a little comparator that just goes
AGC or
backwards and
something
forwards. It
that's
just
going.
goes. It actually keeps it on the moon.
Yeah.
So,
Yeah.
um,
Which is actually what they use, what they can use sort of on the like Mount Pleasant and all
Yeah.
that sort of stuff, and get it to do it automatically. So that's pretty
which is
cool.
pretty cool. So hopefully we can do some beacon tests, because the beacon's got it's got a few issues they're working through. I think I saw a couple of emails go through that they were playing with the TWT. They were sending
Ooh, okay.
300 watts into a 7.2 metre dish.
300 watts at 10 gigs, which is yeah.
Which is here. But I think that the story that I last read was it was running 7 watts.
Yeah. Okay.
So we think that was about, what do we say, that was about 10 dB down on what it was.
Okay.
So I might have a little bit, sort of another 12 of gain with the dish. I should be able to see it at minus 15 or 16. So
Okay. Okay. Cool.
reduce power.
Well, now and we have pics.
Yeah. So this is the picture that it was actually tracking the moon.
Cool. With the moon in the background.
With the moon in the background, yeah.
Up in the sky.
And it went sort of really quite well.
Okay.
It stayed, as I said, I calibrated with because the K3NG has had that uniquely cool bit where you can basically aim and say, okay, calibrate now, you're pointing at the moon.
Yep.
And then you can just hit the track moon button and away it'll go.
Bingo.
And that stayed within, after I calibrated in the dead centre, after an hour it was like on the northwest corner. So it
Yeah. Okay.
was a crosshair.
Okay.
And
Okay.
so I think that was, I'm pretty happy with
That's
that.
well and truly. Well and truly. Now, if you go sideways, I think. Yeah, there we go.
Okay, so that's the picture of the tracker. Again, apologies for the lighting, but it was outside. So the red button is the track moon button saying it was active.
Okay, cool.
Um,
You can.
And that's where it was saying, yeah, it was 83.9. In fact, it was pretty much right on it, 0.1 of a degree difference.
Okay.
So, going that way.
Go
that way.
Go that way.
So that's a bit of an attempt at looking through the
Oh,
rifle scope.
Yeah. Okay.
And that sort of shows you the moon. It's really difficult to actually try and aim and focus.
So where you put the rifle scope on the
Outside.
on the outside of the
because
the
you've
shield.
taken the skirt off yours.
Yeah, no, I haven't. Taken the skirt off. Still got the skirt on there. I've taken the skirt off the 1.2.
Oh, okay. Yep,
The
yep.
1.2 is I actually looked through the dish on the 1.2.
Yeah.
So yeah, but okay, that's good because I was wondering how I was going to do it with the.
So I just picked. You can sort of see there. There's like a joining section where the skirt joins, and it's
Okay.
like a bit of 50 by 6
Okay.
or 50 by 4 aluminium.
Yep.
I thought that's a nice sort of thick, solid piece.
Well, truly.
So I just pop riveted a piece of aluminium
Okay.
onto that.
Yep.
It just looks past.
That
that
aluminium ring.
In reality, if you put a straight edge on there, it probably is close to it, but it's so near that it doesn't
You can
matter.
see past it. Well, truly. You're looking at what x number of hundreds of meters
Yeah.
further out. So
Yeah.
okay.
So that's probably okay. So that's a picture of it. That was a picture at about 4:30 a.m.
Okay.
When I discovered when I got up that, it rained during the night. Great. So it still spat a little bit, so it was just a matter of unhooking everything. So there's the table there with the...
So that's the size, the rifle scope with
covered with a Coles bag.
plastic bag on.
Yeah.
Okay.
So the transverter and stuff is basically attached to the back underneath where that white cover is on the ground. So that normally covers all the radio gear.
Cool. Like that.
Yeah, and the form factor I've built it in so far looks like everything's going to sort of fit. So I can just put that cover on, have like a gland at the bottom for the few cables to come out, so it'll be sort of waterproof. However, I did discover that there's no drain in the bottom of the dish.
No, there isn't.
And I left it up at an angle sort of so it wasn't going to catch the wind, and came out and it was probably about that sort of 6 inches deep of water. So we'll have to fix
A
that.
strategic little hole will fix that.
That's right. But on the desk, that's the laptop with the tracker over there.
Okay.
The GPS unit and the 9700
Okay.
listening for. And of course, whenever you can't hear something, you always second guess yourself, like, have I got the Doppler shift right? Am I on the right frequency? You know.
Right mode, right?
And I should point out too that the dish is set up. I put the feed in for vertical polarity.
Okay.
For listening to the Europeans.
Cool.
And okay, so that's a
there it
fairly
is.
poorly
Okay.
lit bit showing the back of the dish. So that's basically the waveguide switch and
You've
the
got a
transmitter,
little
whatever.
aluminium deck.
Yeah, the little aluminium deck, which normally supported the 600mm dish in its previous sort of configuration, but it's a bit tricky reaching in there with the Allen key to sort of do the things up on the waveguide, but it worked a treat. You see the plastic bag down the bottom holding up, holding the
Encoder.
the encoder.
Okay.
And
here we go.
That's a bit of a picture. So
In daylight.
yeah,
That's. So you've got some decent bits of weight on those corners by the look of it.
yeah. I came by some of these weights that were sort of did Justin and did some dumpster diving.
I love it.
And the idea of those is because I've got 3 jack screws, they're those acro jack screws, to try and get it level. The problem with only having the one in the middle is that it tends to teeter a little bit. Those corners become a little bit heavy.
Okay.
So by putting the 20 kilo weights over the top of the other jack screws, and just by putting one each side of that centre one, it sort of tends to just steady it a little bit.
Okay.
Again, if it gets really, really windy, I'm not quite sure. I might have to. I did have some thoughts of have some telescoping RHS that comes out so you can make
Outriggers sort of.
the ground print a little bit sort of bigger.
Because you've taken the cover off the front, haven't you?
I have, yeah. Look, eventually I want to put the cover back on the membrane over the front.
Yep.
Because where those 3 little wires come out and support the centre of the feed.
Yep.
I want to put like a little bearing there because I want to be able to basically undo the bolts at the back and rotate to be able to rotate at 90 degrees.
Polarity.
To change the polarity.
Okay.
So.
So
that's that. I think that's the last photo.
Well, that is fantastic.
Yeah,
That is just fantastic.
I was pretty happy.
And it's all coming together with the sun and the moon noise that you're getting. Hey, you don't get better than that.
No, well, it's as predicted. So it's sort of fairly good. And as you're well and truly aware, the dish did have a little incident early in its life where it sort of fell down off the support and bent the feed, which is a sort of shepherd's crook feed made out of lovely annealed copper waveguide, which did look very sad. And
yes, because I think I lent mine
yeah,
to you
yeah.
as a pattern.
There was no need to stamp your name all over it. Not getting them swapped over. But no, look, so I spent a fair bit of time with some cardboard templates and soft face mallets and jigs and stuff, and got it. And I think it must have obviously done the trick. So I think the MyTech guys probably did a fairly good job of designing it. Like, it's a little bit sort of forgiving.
Well, the thing, MyTech's a very interesting story actually, because it came out of the RF engineering department of University of Queensland.
Okay.
And they went out and started a company, basically MyTech, and started producing this sort of stuff got lots and lots of orders from, you know, well, the Hydro and many others, because the MyTech dishes are, you know, they've reached their end of life. So you know, they were produced, I don't know, 10 or 15 years ago. They've reached their end of life. They're being replaced, and so there are a lot of MyTech dishes that are starting to become available into the market, into the sort of second-hand market. And
you know, for the ones, especially for the commercial band around sort of, you know, the 10.5 gigs.
Hey,
they're perfect. Yeah.
And in fact, the strong dish, the Reast members who would have got the email on Tuesday,
that six segment one.
There's a 6-pedal strong prime focus, which is, I think Jim Parrish said it was going to be like a 12 gig. Yeah,
for X band or K band.
And it's a pole mount, but that's a 1.8 metre solid 6-pedal dish.
It's designed for 12 gigs, so it'll be
well and truly
great for.
So yeah, and it is literally, it's still in its box. It's still in its box. It is, you know, old stock, as I say. Never been assembled, and all the instructions and everything are in there. So yeah.
You could pick up.
Well and truly. So yeah. Yeah. Let's go back to us.
Go back.
Now, just stick around, because there is a absolutely fascinating. Came across this the other day. I'm on a number of amateur radio related Facebook pages, as we are, and there is a wonderful one called Making Antennas for Amateur Radio. Now, the thing that jumped out at me here was Dennis Mosser posted this wonderful story about, here's a chuckle. I took an old school folding aluminium chair, and we all remember those chairs, and converted it to a omnidirectional square halo, a squalo, as they are known, and it performs beautifully. This is essentially the same antenna as the M2 offered at $200. My cost? Well, the chair was free, and I put about $20 worth of aluminium tube and Teflon rod into it.
Supposed to be M squared, I suppose.
M squared, and that his 6 metre, basically his 6 metre loop antenna.
Well, that's pretty cool.
So yeah, and antenna provides a 1-to-1 match and has a usable bandwidth of 300 plus kilohertz. So hey, doesn't get much better than that.
Especially it's got rid of that pesky chair that I'm sure he's jammed his finger on a few times.
So I just thought, oh, that has certainly got to have some brownie points there. So yeah, but anyway, that's now. While you're here, Ben, who is always eager to send through wonderful little tidbits of bits and pieces. Now, for the conspiracy theorists amongst you, Ben sent through from a website called Conscious Copper a lattice home EMF defence device for the princely sum of $68, and it is a home EMF, so I assume that means electromagnetic force, yeah. Electromagnetic force, effective for 5G, and embedded beam system, and that's a trademark.
That's a trademark, yes.
A range of 500 square feet per room. And works in any room of the house, and it has a dual room placement.
Yeah.
So you actually
shut up and take my money.
You select the number of rooms that you want it to cover, and now after I something in me just said, I've seen one of these somewhere else.
Looks like a heatsink off or something, right?
Well,
off a Raspberry Pi.
I happened to go to Jaycar. And I'll just point out here the cost here is $68, and I think that's $68 US. If we go to Jaycar, we get 2 of them for $7.95 Australian.
Wow.
And they're sold as copper heatsinks for Raspberry Pis. So
Well, goodness gracious.
I just went, oh dear, oh dear. Now the other thing that the other item that I just wanted to point out here, one that we had a little while ago, was here's I think we pointed this out a little while ago back. As the ultimate Christmas present, I think it was, because around Christmas time this became available. And this is a Wi-Fi router guard cover. Blocks EMF exposure while you can still use your router. Well, nah. But the key thing is here is it blocks 5G signals into your Wi-Fi router.
Yeah.
So this is basically a Faraday cage for your Wi-Fi router. So,
I'd be really interested to know how many of these they've actually sold.
Well, this is Amazon. This
Yes.
is actually Amazon. So, and they're at the princely cost of $69.90 US.
Was there a bigger model up there?
Oh,
Larger.
Well,
That's a larger one. Blocks
Wi-Fi.
90%.
Yeah, of your EMF while you
Wow.
can still the large. There you go. Smart meter guard. You can put 3 or 4 routers in that.
Oh my! They walk among us.
They do, and people pay reasonable amounts of money for this sort of stuff. But I did like the copper. That's a princely sum of $68 US, whereas I can actually buy 2 of them for $7.95.
Some of the terminology, and that's like those other YouTube clips, where the guys just talk all the technical words and actually don't.
Correct. Yes, it's the
Dual equilibrium.
the audiophile cable, which is oxygen free, copper.
Oh yeah.
So anyway, that's a little bit of fun. But anyway, so what I might do, Richard, is thank you very much.
Thank you very much. I might grab Lee.
Well and truly, and
Alright.
get Lee in here. Lee has made an antenna, a FlowerPot antenna. So we'll get him in and.
Alright.
So thank you,
Scott,
Richard, and good luck with the further experimentation.
You will be the second to know.
Woo! So this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night, and we'll just get Mr. Lee in, VK7LEE, and we'll show off his new FlowerPot antenna. So what we've got coming up after that is we have some very nice new PTZ cameras. Come in, Lee. Some very nice PTZ cameras that I'll show you. Yeah, just watch the light. And we've got Lee, VK7LEE, in the studio. Good evening, Lee.
Good evening, how are you going?
I'm well, yourself?
I'm very well, thank you.
Oh, and you took your top off. Oh, I like the other one.
I'm not sure everyone needs to see the Kylie Minogue TikTok.
Yeah,
But never mind.
definitely. we like Kylie Minogue on the ATV night.
I'm nervous enough as it is.
So, now you have in your hot little hands a something. What is it?
Okay, so this is a FlowerPot antenna.
Cool.
It is the brainchild of, I think it's VK2 guy. I can't remember his exact call.
Something.
Yes.
Yeah, okay.
I should have checked that before I came in.
That's
Basically, it is, in fact, at its basic level, within here is an exposed section of coax with the dielectric still attached.
Yep.
Then there's about 450 mil of that. Then beyond that, there's another 440 mil of intact coax,
Yep.
which then appears down at the bottom. This is obviously the choke,
Yep.
and had to experiment with this to get the right number of turns, to get the
Okay.
right SWR. And then once I had this tuned up for 2 meters, which is what this one's designed for,
Great.
there is then a mod which you can add, which is basically tinfoil along here,
Okay.
covered in PVC, and that allows you to, that acts as a secondary element for 70 centimeters.
Cool. So 2 and 70.
Yes.
And what sort of SWA are we talking here?
SWR on 2 meters was about 1.3 to 1.4, depends on when you
Lovely.
hold it, and 70 centimeters about 1.1, 1.2.
Fantastic. Doesn't get much better than that.
And given this is my first one actually built at home, then I was actually quite proud of that.
Well, truly. and Lee was one of the features last week at our RD contest forum. His first Remembrance Day, along with Harry and Xavier, who were also out there. So yeah. Did you use this during the RD, or is this a recent
This is a recent
creation?
This is a recent creation. This was literally done on the Thursday evening while I was, quite frankly, sat bored doing nothing. I thought, and I'd gone to Bunnings and got some polypipe in preparation.
Cool.
What was quite amusing was when I actually went to test on the weekend. Harry was also testing an antenna.
Okay.
And so, quite by accident, we ended up testing our antennas
Together. Oh, I love it.
Kind of cute.
Talking to each other on new antennas, that's always a good thing. Well, that's fantastic. Look.
Yep.
So what's the next project in the pipeline?
The next project in the pipeline.
Oh, that was bad, wasn't it?
As bad as my resistance jokes.
Yeah, Murray. By the way, Murray is still out there with Richard sorting resistors. If you remember from last week.
If I make any more resistance jokes,
they didn't go home. They've just been here all
They're still there. Yeah. We locked them up. The next project, which I'm currently halfway through, is building a dipole, which with a custom built centre, again made of polypipe, and I'm just at the stage of making or learning how to make the RF choke for that. The balun, I should say.
Yeah.
For the choke.
So what frequency are we talking here?
That'll be 80 meters.
Okay.
But I've actually made it modular so I can replace the two. There'll be a quarter wave dipole for 80 meters. But I made it modular so I can actually unplug the 220 meter
elements.
lengths.
Okay.
And plug in a 40 or a 20. Sorry, a 20
Nice.
or a 10.
Nice.
So I can get different bands. Not easily, but certainly not difficult. Basically,
Okay.
just using banana plugs. Plug in.
Okay.
I will bring that in when it's done.
Cool. No, well and truly. So you're going for separate elements. You're not going for like a trap, an inductive trap or something like that. No?
I was thinking of it, but I'm kind of my thinking was that because I'm still new to all this, and because I think that I learn by doing.
Okay.
And so I thought build a basic single band first of all, and then once I've got that working and I'm comfortable with it, then I'll start looking at some more exotic ways of doing things with an inductive trap.
Okay. No.
And also the next project, once I've got this note, will probably be a fan dipole.
Okay.
Yeah.
Yes.
Yeah.
Yeah.
So yeah.
They're very effective, and you actually don't need that much room, but very effective and very easy to tune, unlike other antennas, which can be a bit of a challenge.
Yes, yeah. I mean, this one I think it was one challenge I had with this was getting the 70 centimeter element in place.
Yep.
I had the SWR meter just literally with the little bow thing, which is one of my go-tos.
A bit of power. Yes.
Yes. A bit of energy, and SWR plugged into that, and I was literally just moving this up and down, doing test. Well, I think it went. The SWR went 1.7, 1.6, 1.4, 7.3. Oh no, maybe not. Move back up a bit, and just literally moving up that way, back and forth.
Yep.
And that was that. And then as soon as I got it in place, then
stick it in. Yep.
And with some self-fusing tape.
Yeah. Okay.
But
very good.
Yeah, learned a lot.
No, well, that's what it's all about.
Yeah.
It's that experimentation side. So, and you've ended up with a 2 and 70 centimeter antenna that's much better than what's on your handheld.
It's just slightly larger as well.
Yes.
One of the problems I find is that when I listen to the broadcast, and who doesn't, please listen to the broadcast on a Sunday morning. I need to be outside to actually transmit a callback.
Okay.
And some days it's not the best weather for staying inside. To do
just
a
of late,
callback.
yes.
Yeah. And so I kind of went with, well, I need something to see really that, and also HF contesting. It'd be kind of nice to have something actually take out and have outside the car if it's raining, or just something that's a bit more powerful.
Yeah, well and truly.
Yeah.
Well and truly.
And
And the beauty of that is you can That is vertically polarized, and if you turn it round at 90 degrees, well then it's horizontally polarized.
Yep.
So
it's also being called variously a lightsaber and curling
yes.
tongs, but
yes, amongst other things.
yes, which of course you and I both have to hear for.
Correct. So that's fantastic, Lee.
Thank you very much.
And congratulations for
Thank
your successful. Is this your first antenna that you've built?
This is my very first one.
Well,
Yeah.
there you go.
And I could not have done it without. I'll say now I couldn't have done it without the guidance from that I found from, which you say was one of VK2.
Yep.
And the encouragement that I get from everyone.
Cool.
In the club.
Cool,
It's fantastic.
Cool.
Yeah.
No, and the FlowerPots are well known, and they're antennas that you can't go wrong with.
Mhm.
Honestly, they're very easy to put together. And lots of club projects have been FlowerPot antennas. So because you can actually you can put it together relatively quickly, and it is almost fail proof. So yeah.
And the great thing is it's cheap.
Yeah.
You're probably looking about $30-40 total.
Yep.
So, and most of it's stuff you had around at home.
Yep.
So yeah, it's fantastic.
Good stuff.
Thank you.
Thank you, Lee.
Thank you very much.
And is this your first segment? On
It is my first segment.
Oh, there you go. There you go.
Yeah, two new things in one night.
Woohoo!
So,
That is fantastic.
thank you very much.
Very good. All right, thank you, Lee.
Thank you. I'll try not to hit the light in the way.
No, that's all right. That's all right. Okay. So what we've got now is a bit of a follow-on from a couple of weeks ago. I showed the start of our new, and in fact what I need to do is go, just bear with me as I head down and across and over and under and through, and here we go. Now what are we looking at? Well, we're looking at a Dalek. No, we're not. We're looking at a those people from the security industry will realise what this is. And in fact, when you walk around Hobart, you've probably seen quite a few of these. Probably not in this form, but with its shell over the top of here. But these are dome cameras that I used in closed circuit television systems around Hobart, and they're currently being replaced. And we're very lucky to be able to get a few of these, so that we can replace the cameras in the studios and out in the room. But I showed a little bit of the code last time. Now we've got the code all working, and so what I can do here is you can see this is the PTZ. So this is the pan, tilt, and zoom functions, and you can, if we go, here we go. It helps if you actually power up the control box. Just let me plug that in. Now we just powered up. This is just so that I explain. This is the Arduino Uno board. There is a shield on here, which is an RS485 shield, which is the control for these cameras. Comes off. It's a little 3-wire control where you can serial up, parallel up everything, and each of these cameras has a ID that gets transmitted by the control board, along with the command and the data stream that enables you to control these cameras. So this is the pan in either direction, the tilt. So this is the tilt on the camera, and then if we zoom around so that I'm actually looking at the camera, there we go. You'll be able to see the zoom function, and you can see the lens disappear inside there. It's zooming in and out here. And on these particular cameras, the output comes out as a composite output. So there's a bit of coax that we can connect. I probably should have connected it up to one of our video inputs, but anyway, let me see whether I can do that. Just bear with me, and I'll grab a cable and see whether we can't connect up to a to one of our video inputs. There we go. We don't usually use video input 4 on this particular mixer, but hey, what the hell? We've got the technology. We can do this. We can well and truly do this. So that's I'll just switch to video input 4, and there we go. So that's video input 4, and you can see this is the zoom function. We're zooming into the camera that we were on just a moment ago, and there is an autofocus function that's going on here. That's the tilt. That's the tilt, and this is the pan. So you can see, here we go. There's me. Now everything is upside down because this camera is normally mounted upside down. So yep. That's the pan, tilt, zoom function and these cameras, you can do the full 360 and you can do the full tilt. In fact, the tilt automatically changes over at the top. There we go, and back over the other side. So you've got full control of a pan, tilt, zoom function. Everyone's getting seasick out there, I reckon. And zoom out there. Now I'll just change back to the other camera. So that's the Arduino that we use for. Let's zoom out there and just come back up again, and I'll just very quickly take you through the code, which is remarkably simple. Now we've got the I'll just get the that's a bit better. Back over this way. So if we go to all right, now for those who don't know, this is the Arduino. This is the Arduino development environment that comes. It's free, available from the Arduino website. Now you'll see here there's a whole lot of masks that are available to us here, which are used throughout, so you can superimpose particular control signals on the byte for the command and the data. A whole lot of setups here. Now, since I last showed you this, you'll notice that there is an include at the top here. This is a library. I actually use a library called ezbutton.h. Now, this is a debounce routine. Whenever you have switches, analog switches, and you're using a microprocessor to actually sample whether the switch is down or not, you need what they call a debounce routine. And the debounce routine, what that routine actually does is it sits there and samples and counts the number of times that it's seeing the button down, and if it's if it's down for a particular period of time, and in this case we've specified 20 milliseconds, which is one cycle of 50 hertz. If it's down for 20 milliseconds, it sets a little flag that says, yes, this button is actually down. Because the problem is, when you press the button down, what you actually see, what the microprocessor sees, is it making contact, not making contact, making contact, not making contact, and eventually all of that settles out, and it's making contact 100% of the time. But if you happen to be sampling at the time that it's actually transitioning, then it may say that the button's not down or the button is down. So the debounce routine basically says it just goes off, and if the button's been down for 20 milliseconds, it actually sets the flag that says yes, the button's down. And then the reverse happens when you release the button, because then the routine makes sure that the button's been up for at least 20 milliseconds before it unsets the flag or sets the flag, depending on how you set it up, to say that the button's actually been pressed. So there's a wonderful little library routine called EZ button that you can include, and there's a little bit of setup that you've got to do with EZ button. So you do the readme, and you set up the buttons, and I've got zoom in, zoom out, tilt up, tilt down, pan left, pan right, and this also sets up the pins on the Arduino that they're actually connected to. Then there's a little bit of other setup we've got here. That particular camera is camera address number 4. You can have up to 256 different addresses in a camera. They're set up by little dip switches. There's a couple of other things in here. The actual flags that we use for zoom in, zoom out, tilt up, tilt down, pan and right are set up, and they're made sure that they're 0. And there's some other variables that we put in here. Specifically, and the very important ones are command 1, command 2, data 1, data 2, the checksum and the ID. And this is sent as the serial stream to the camera via RS485. Set up baud rates, which is 9600. We actually send that to the camera with the camera address, and we go through in a little initialization routine, which I'll go into in a sec. Now, one of the things that I found out after a bit of experimentation was the camera. The camera worked quite well. It was pan, tilt, zooming, and everything was wonderful. But 4 minutes after I'd moved the camera to a particular position, it would zoom back to a preset 1. After I did a bit of reading about the Pelco D protocol that it actually uses to control the camera. And so I thought, that's a bit of a bugger. I have to actually unset that preset. And preset 1 is actually the first preset, and that is the default preset that it goes back to after a particular timeout. And in this case, the timeout was 4 minutes. So I could clear that preset, which I actually did, but then I looked and found that there is actually a command where you can send the camera a 41 in command 2. So I set up command 1 to be 0, command 2 to be 41, which is 29 hexadecimal, data 0 and data 1 0 and data 2 0, and I've put the comment in here, the camera resets to the default, so it also does clear those presets as well. Now, to get the checksum, there is a checksum that's sent at the end so that the camera knows that what it's just been sent is a valid data stream, is an actual data command. So the checksum is the product of the ID, the command 1, command 2, data 1 and data 2, and that checksum's in here as the product of it. And then it sends out the serial command stream, which is the first byte is always FF, so everything on. Then it's the camera ID, command 1, command 2, data 1, data 2, and then it sends the checksum at the end, and then it switches off the RS485 module. Switches it on up here, switches it off down here. So that's the very first bit here, is it sends a reset to the camera. Made sure that there's no presets set or anything. Now, a bit of setup here for the EZ button library. And you'll see this is where you set the debounce time set to 20 milliseconds, and that's for each of those particular buttons that I'm monitoring. Now we go into the void loop. Now in Arduino speak, void loop is the main loop that it sits in and goes backwards and forwards in that loop, goes through that loop, then starts again and goes through that loop and continues to loop through. So this is the main area that the Arduino sits in most of the time. And you'll notice that it's calling each of the buttons through a little function called loop. The init state, it actually reads the state of each of these buttons, and then I go through a whole lot of little if statements, which is If it's pressed, then set a flag zoom in to 1. If it's released, then reset that flag, etc., for each of the buttons. And then the very last thing it does is send the PTZ command to the camera. So it sits there. Now, what it then does is sit here. There's a little thing that says PTZ Cam. So this is how it sends that command to the camera. So that's how it sends it. It calls that and sends it. This is the initialize routine, which all it's doing is switching on the RS485 module through, and that's just enabling a particular output pin. A little bit of setup, and it then goes through and a little bit of setup around the pan and tilt functions, because the pan and tilt it has some limits that you have to set up so that it doesn't go past those limits. And you can see there in those cases that it has to be less than 127. So the maximum is 128. Now what it does here, the very interesting thing here, and I'll demonstrate it in a short while. One of the really nice things that this bit of code does is, if you are really zoomed in, so you're zoomed right in on something, what it does is the pan and tilt speeds, it adjusts those speeds so they're much slower when you're zoomed right in. And that's really good, because when you're zoomed right in, you don't want these sudden movements of really quick pan and tilts. So what it does is it slows the speed at which it pans and tilts really slow, and then as you zoom out, it speeds those up so that you get to the maximum speed, which I set at about half the speed it can go, which I think is fast enough. Now there's a few comments in here about what the different bits in the command and the command 2 do. There we go. And data 1 and data 2, when you're panning and tilting, sets the speed. So data 1 sets the pan speed, maximum of 63, minimum of 0, and 0 is stopped, so it won't do anything at 0. And then at the tilt speed, exactly the same. So we turn on the module. The ID is the camera address, which we've set earlier on, which is number 4. We zero out all of the commands, and then we check the buttons. So is the zoom in button down? It sets up command 2 to be 32, which is the command for doing a zoom out. Or if it is a zoom out, then we send it a command 64, which is the telephoto, so zoom in. The focus, it just sets up here as autofocus, so it automatically focuses, which is good. We want that because we don't actually have a focus function here. We could put a focus button on there if we wanted to, but the autofocus is not bad on these cameras. The pan and the tilt, exactly the same. Is it panning right or left? And set up the relevant commands. We set up data 1 as 32, so set the pan speed to medium. And then on the tilt, exactly the same, but it's command 8 and command 16 on command 2. And again, we set that data 2 to the tilt speed, which is at a medium speed to start with. We do some checks whether they are within the bounds of what it can send, because if we send it something invalid, it'll just not do anything. And then the key thing here, which is one of the things I've had to add in this code, along with the other things, was check whether it is basically in a state where none of the buttons are pressed. If none of the buttons are pressed, then basically what it does is it sets everything to 0 and then sends that to the camera, and setting everything to 0 stops, and it sits at that particular pan, tilt and zoom position until further notice, until it gets some more commands. And then send out those commands and write out the stop sequence, which is what it says here. Forget this is the clear preset command that I was playing with, so I don't actually need that anymore because I'm resetting the camera at the beginning, so I've left that in there accidentally. Generates the checksum using the ID, the command 1, command 2, data 1 and data 2, and then it writes them out in the right sequence. So FF, all bits on, the camera ID, command 1, command 2, data 1, data 2, and then the checksum. And then it switches off the RS485 module at the end. So that is as simple as the code is. And that's the control that we're actually using. One of the things that I'm just working on is we will end up with at least 3 cameras, 2 in this studio and 1 out in the room. And so what we really need to do on this control module is have probably 3 or 4 buttons that enables us to select the particular camera that we want to send those commands to, and it'll then take into account that button 1 is camera 1, button 2 is camera 2, button 3, etc., etc. And so you can select, when you select that, it'll switch a little LED on so you know which camera is selected, and any commands that then get sent using the PTZ buttons then get sent to the right camera. So yeah, and the next thing to do after that would be to, I do actually have one of the Arduinos that's got the Wi-Fi built in, is to get it onto the Wi-Fi and then use like a smartphone app or a tablet app or something, probably an Android app, to control it so that we can actually be anywhere in the facility here and be able to then control those cameras remotely via a tablet. So anyway, that's the development roadmap. But right at the moment we have a working, and I'll zoom back down again and I'll show you. This is a really nice feature. The little feature that bears in mind how zoomed in you are and adjust the speed accordingly. So let me just go to. Okay, that's the speed that's coming from the camera, and you'll notice that we're zoomed right out here. So the pan and tilt. This is the panning. Panning is that's half speed. It can actually go faster than that, so it can really actually really make you seasick. Now, if we zoom right in, there's the roof up there. That's zoomed right in. If I now pan, you'll notice it's slowed right down. So it only pans really slowly, and the same with the tilt. The tilt zooms. The tilt is speed is quite slow. If I come back out again, just to prove this, right back out to its maximum, we're back to the normal tilt and pan speed. Oh, there we go. We've just disappeared into our own black hole. That's a bit of a funny effect, isn't it? So we're back to the normal speed. So that's a really nice little feature that enables us to just to control it. So when we zoom right in, of course we don't want sudden movements and that sort of thing. Well, you can see the structure of our acoustic tiles. But if I now tilt, it's really slow tilt and really slow pan, which is what you want. So you're not getting really jerky motion when you actually pan and tilt when it's zoomed right in. If I go to about halfway, it's about half speed. So it just goes to prove it's about half the speed. If I zoom back out again, right out to the very limit, we're back to our normal speed. So so there you go. There's and we're back. Oh, can't even drive this myself. Anyone would think I was a drunk driver. And we're back to our original camera. So so there you go. It's one camera looking at another camera. So anyway, that's we'll come back up again. Unfortunately, I didn't build the same thing into the controller that we're using right at the moment. So it's definitely a step in the right direction. It's one speed with the controller that we've got right at the moment. But anyway, that's a little bit of the PTZ cameras, and we'll show you those when we install them. We've got 3 of them, thanks to Anders Marchant, who's donated them to the cause, which is fantastic. So thank you, huge thank you to Anders. Now, quick reminder of our presentation night, which is this is our last DATV night for August. Next week we go to we have our presentation night, which is P25 Emergency Services Radio Network build with Andrew VK7AJ. So the Tas Government Radio Network, which is currently being built, so should be a fascinating talk. In October, now October is on Sunday the 3rd of October. We're actually having a weekend one with a barbecue, and then a presentation by Peter VK7 KPC and Kim VK7 KB on all sorts of military radios, so man-pack radios, so absolutely fascinating. And they'll actually be setting them up out in the compound with the antennas that go with them and demonstrating them. And then in November, which is the 3rd of November, we've got all about digital hotspots, digital voice hotspots with Scott, VK7 HSE. That's our November presentation night. And in between all of that, we'll have the DATV nights. So anyway, that's and we've got a whole lot of videos for our RF viewers tonight. A whole bunch of all sorts of different videos on winding transformers, on IC fabrication processes, measuring the speed of light, flywheel batteries, and crazy flying machines and all sorts of stuff. So anyway, that's for our RF viewers. Anyway, thanks for listening. Hope you got something out of that. And this has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night and 73. And we'll catch you in a fortnight's time at our next ATV night. Cheers.